When summarizing or describing a variable, it's often helpful to talk about where that variable or the data, where does that data lie? Where is the data located? And to do that, what we often turn to are measures of location, or more specifically, where's the center of the data? Where's the data hover around, or where's kind of the middle of the data? And so due to this, we often turn to a number of different calculations, which in some sense are often summed up in the term average. Now, as we'll learn, that term average is not very specific and can be a little confusing because there are more specific or more defined ways to talk about what it is we often are talking about. Often the term average is used to mean the mean, but sometimes you'll see people use it to refer to the median and other calculations as well. So we're going to be more specific here. If I do say average, it's probably in reference to the mean. But as we all try to break away from our conventional language and be more precise, I'll try to say mean. So we are all probably familiar with the concept of mean and even median. One thing that we may not be as familiar with is the use of symbols to represent different concepts. And so this is kind of going to be our first foray into really needing to learn what certain symbols mean. And I'll tell you why that's important is we're going to learn how to calculate the mean here. But as we'll notice, there's a couple different means that we're going to calculate, one regarding the population and one regarding the sample. And as we talked about in earlier chapters, there's a difference between when we are focusing in on the population or focusing in on the sample. And the reason we need to start learning what symbols refer to which calculation is because in future chapters we're going to rely on something like the mean, but the symbol is going to tell us if this is the sample mean or the population mean. And so I'm just going to write them both down. The population mean, and I will write them if this registers my pen mark. There, the population mean is written as the Greek letter mu, kind of looks like a U. Mu, and that's mu phonetically. And then all that is so this is the capital Greek letter sigma. And whenever you see the Greek letter sigma, it simply means summing or the summation. And we'll talk more specifically what that means when we turn to it. But I just want to write these both down so we have them. And that's divided by n, where again n is going to be the number of observations or the number of numbers that we're dealing with. And then the sample mean is going to look very similar, except this time we're going to use x bar. We refer to that as x bar. And that is also going to be the summation of x. And then that is divided by n, but this time it's a lowercase n, just to reference or to remind ourselves that we are dealing with a different n. Okay, it's not the population. Let's say we have 300 people in our population, but we have a sample of 20 of them. That lowercase n is the sample number 20. Okay, so these are both calculated very similarly, but they may be different, or there often be different numbers, even if we're taking from a sample from the same population. And so one thing to note is that we can talk about the mean and mean both of these things, okay, or both of these reference a mean. And in future chapters, it's going to be important to be able to distinguish, I need to plug mu in here, so I need to plug the population mean in, not the sample mean. So take note of that as you practice and work through some of the problems here in chapter 3, is that we want to be mindful of what specific calculations we're doing. Now, when it turns to actually calculating the mean, again, this is probably not going to be brand new to many of you, but the summation largely is. So let's set aside the equations that we've just written. If I want to take the mean of, I'm just going to flip pages so we're not too distracted there. If I want to take the mean of some numbers, so let's say I have 4, 7, 3, and 6. Okay, the mean of this, right, is simply going to be, what do? I add them all up. Supposed to be a plus. Sorry for my penmanship. 4 plus 7 plus 3 plus 6. And then I divide by the number, right? So there's 4 here. And what is that? 11, 14, 20. So 20 divided by 4 is 5. Okay, so the mean is 5. Maybe, and if this is the population, then that would mean that the mu is 5, right? If this was the whole population of your family, let's say there's 4 people in your family, and those are the number of corn on the cob you can eat in one sitting, then on average, your family can consume 5 cobs of corn per person. Fairly impressive. Okay, so we are all familiar with this form or this method of calculating the mean. When we put that into the equation, all this is up here is the summation. We're adding up each value in the series, right? So when I sum over x, then this is equal to 4 plus 7 plus 3 plus 6. Okay, and so then when I do sum over x divided by n, that's going to be what we just did. 4 plus 7 plus 3 plus 6 divided by 4, where n is equal to 4. Okay, so the notation there is just a shorthand so that we can say, hey, add up all of the stuff contained in x, where x is the variable, right? So in this case, x is a variable which contains these 4, right? Or you know, when we list it out, it might be you and your sister and your brother and your grandma, and you ate 4, 7, 3, 6. So if we're visualizing it more as kind of a data set is going to be laid out, what we're asking you to do is to sum over the x variable, and x is just taking the general sense of whatever variable we want to take the mean of, sum over all of the observation values there, and then divide by the total n. And so let's say we didn't have data, and this is going to kind of be a silly example because we do have data on all these, but let's say we didn't have data on this, but we had taken a sample and we had just gotten 7 and 3. We had taken a sample of your sister and your brother. We would then, to find x bar, we would take the sum over x. Okay, so now in this scenario, we don't actually have the full x. We just have the sample, which is going to be 7 plus 3. This is going to be divided by n. 7 plus 3 divided by 2, right? And in this case, we also get x bar equal to 5. Now, I want to warn you that that's not always going to be the case, right? So the sample mean is not always going to be equal to the population mean. And I probably shouldn't have started with such a nice example that allows that to happen. So because it's totally feasible that we wouldn't have taken your sister, we would have taken your grandma and your brother, and we get a sample mean of 4.5. Okay, so that's largely the big takeaway I want you to have from the mean discussion is obviously, number one, how to calculate it, but number two, that we do need to keep in mind if we're dealing with a population mean or a sample mean.